Some extra examples for solving logs. If log base x of 125 equals 3, find the value of x. So find what the base is. So we have log base x of 125 equals 3. So using our scorpion tail method, we have x to the power of 3 equals 125. So x to the power of 3 equals 125. So 125 equals x cubed. Well, 125 can be rewritten as 5 to the power of 3. We can cancel the cubes on both sides, and we're left with x is equal to 5. Evaluate 2 log base 2 of 2 plus log base 2 of 12 minus log base 2 of 6. Now this example doesn't actually require any solving. It's just evaluate, which we can also say is simplify. Or just basically work out the value of. Okay, so we have 2 log base 2 of 2 plus log base 2 12 minus log base 2 of 6. So the first thing we're going to do is use law number 3 to bring this 2 up beside our argument 2 as a power. So it's basically using law 3 in reverse. So usually we bring the power down in front, but in here we're bringing the number that is in front of the log up as the power. So we have log base 2 of 2 squared, and the rest stays the same. 2 squared becomes 4. So we have log base 2 of 4 plus log base 2 of 12 minus log base 2 of 6. So since we have 3 separate logs, we want to simplify so that we only have one log, and again it's base 2. So the plus becomes multiply using law 1, and the minus becomes divide using law 2. So we've log base 2 of 4 times 12 divided by 6, and 4 times 12 divided by 6 is 8. So we've log base 2 of 8, which gives us 3. Because log base 2 of 8 equals 3, because using our scorpion tail method, 2 to the power of 3 equals 8. 2 to the power of 3 equals 8, so we end up with 3. Solve for x. Log base 2 of x equals 3 minus log base 2 of x minus 2, where x is an element of the real number set. So we have log base 2 of x equals 3 minus log base 2 of x minus 2. So what we want to do is get all the logs on one side. So we're going to grab hold of this minus log base 2 of x minus 2, bring it over the equal sign, and it becomes positive log base 2 of x minus 2. And in front we have log base 2 of x. And this is all equal to 3. So basically you just grabbed hold of this, brought it over the equal sign, and it became a positive. Now we have 2 logs on the left of the equal sign. Both of them are a base of 2, so we can use law number 1 in reverse. So we're going to make this add become multiply. So this plus becomes multiply, and basically stick these together with brackets. So we have log base 2 of x multiplied by x minus 2 is equal to log base 2 of 8. So we've basically just changed this 3 for log base 2 of 8, because 2 to the power of 3 is equal to 8. And the idea behind this is that we'll eventually just have 2 logs on either side, log base 2. So next we're going to multiply out the brackets. X by x is x squared, and x by minus 2 is minus 2x. So now we have log base 2 of x squared minus 2x on one side. That's equal to log base 2 of 8. So now we can cancel out our logs because they have the same base. We bring down the x squared minus 2x, and we bring down the 8. So we just cancelled our logs in that step. Now we bring the 8 over the equal sign, it becomes minus 8, and now we have a quadratic trinomial. So we factorize, so we get x minus 4 multiplied by x plus 2. And then we solve. So x minus 4 is equal to 0, so x is equal to 4. And x plus 2 is equal to 0, so x is equal to minus 2. So our solutions are x is equal to 4 or x is equal to minus 2. However, we're actually only going to go with x is equal to 4. So we reject x equals minus 2, as substitution into the original equation, which is up here, yields log base 2 of minus 2 or log base 2 of minus 4, which are not defined. So we cannot have a negative number as our argument. Therefore, x is equal to 4 is the solution, which can be checked in the original equation. So if we were sub in 4 into the original equation in place of these x's, we will get our equation to balance. Sometimes a change of base is required, and law number 5 is our change of base law, so we're going to have to use this. Solve for x, log base 2 of x plus 4 log base x of 2 is equal to 5. So notice we have a base of 2 and a base of x. And in order to use law 1 to 3, we have to have the bases matching. So solve for x, log base 2 of x plus 4 log base x of 2 is equal to 5. So we first write the equation in terms of one base only. So log base 2 of x plus 4 log base x of 2 is equal to 5 is what we started with. We're going to keep the base of 2, so we write down the log base 2 of x. And we're going to keep the plus 4, and we're going to change log base x of 2 to 1 over log base 2 of x, and it's still equal to 5. So let's have a look and see where this came from. So using our change of base law, so in our original log we had log with a base of x, so that's the a, and as we can see in our formula, the a then goes into the denominator as the argument. So we end up having log with an argument of x in our denominator. We want the bases to be 2 because remember we're trying to match up with this here. So we can choose whatever base we want. In this case we're going to go with 2. So our bases, our b's here will have to be 2's. And then our original argument, which is 2, which matches up with x in our formula, is the argument in the numerator now. So it goes up there into the numerator. So log base x of 2 becomes log base 2 of 2 divided by log base 2 of x. So you basically just split it up. The base is the argument in the denominator. The original argument is the argument in the numerator. And you put whatever base you want, so long as it's matching the same on the top and on the bottom. In this case, we want 2. Now, log base 2 of 2 becomes 1 from law number 4. And log base 2 of x just stays as log base 2 of x. So that's how this became this. Now don't forget the 4 in front with brackets. So we bring down the log base 2 of x, and multiplying in the 4, we basically just put the 4 on the numerator. So we have 4 over log base 2 of x is equal to 5. Now remember we're asked to solve. So solving requires solving, but sometimes it requires factorizing first. And this is a little bit messy. So what we're going to do is we're going to replace the log base 2 of x with something else for the moment. So when we do that, we usually just use a y. But you could really use any letter you want here. So we're going to let log base 2 of x equal y. So we're going to swap this for y and swap this for 4 over y. So everywhere we see log base 2 of x, we swap it for y. And that's still equal to 5. So next we're going to multiply across by y. And y multiplied by y is y squared. And 4 over y multiplied by y, well the y's will cancel, leaving us with 4. And 5 multiplied by y is 5y. So we did this because we wanted to get rid of this fraction. So we have y squared plus 4 is equal to 5y. And bringing everything over to the left-hand side, we have y squared minus 5y, so that plus becomes a minus when it goes over the equal sign, plus 4 is equal to 0. Now we can factorize to get y minus 4 multiplied by y minus 1. And then we can solve. If y minus 4 equals 0, then y is equal to 4. If y minus 1 equals 0, then y is equal to 1. Now remember, we were not asked to solve for y, we were asked to solve for x. So we now have to go back and use our log base 2 of x equal to y. So we come over here. So we had y is equal to 4. So y is equal to 4. Now we go back and substitute y for log base 2 of x, because remember that's what we swapped it for. So we have log base 2 of x equals 4. And then we do our scorpion tail method. So 2 to the power of 4 equals x, or x is equal to 2 to the power of 4. And 2 to the power of 4 is 16, so x is equal to 16. And likewise with our other y value, which was 1, y is equal to 1. We again swap the y for log base 2 of x, so we just swap these. So log base 2 of x is equal to 1. Using our scorpion tail method, 2 to the power of 1 equals x, or x equals 2 to the power of 1, and 2 to the power of 1 is 2. So we were asked to solve for x, and our x values are 16 and 2. So here we have an example using simultaneous equations. Solve the simultaneous equations. 2 log of x equals log of x plus y, and log of y equals 2 log plus log of x minus 1, where x is greater than 1 and y is greater than 0. So let's start with 2 log of x equals log of x plus y. So notice here that we have no bases first of all. So if we see a log on its own, we just take it to be a base 10. But it doesn't matter in this case because it's not so much a log question as an algebra question. It's actually a simultaneous equations question. So what we're going to do is use our laws of logs. The bases happen to already match even though we don't see any bases. And we need to solve for x and y. So we have 2 log of x. So the 2 is going to become the power. So we have log of x squared, and the right hand side stays the same, equals log of x plus y. Now we have matching logs on either side, so there's no base, which means they are base 10, so we can just cancel out the logs, bringing down x squared and the x plus y. So here we have equation number 1. And then we do the same with the other equations, so we've log of y equals log of 2 plus log of x minus 1. Again, we've no bases, so we just take them to be a base 10. So this plus becomes multiply using our laws of logs. So we end up with a single log, and then the 2 gets multiplied by the x minus 1. So now we have a single log on either side, so we can cancel them out, bring down the y, and bring down the 2 times x minus 1. And here we have our second equation. So now it's just simple algebra. We take our second equation, y equals 2 times x minus 1, and we put it into the first equation, which was x squared equals x plus y. So we always substitute the linear or the simpler equation into the quadratic. So we have x squared equals y plus x. We're going to swap that y for 2 times x minus 1, because that's what we stated it to be equal to. So replace y with 2 times x minus 1. Then we multiply out the brackets. 2 times x is 2x, 2 times minus 1 is minus 2. So we have x squared equals 2x minus 2 plus x. We bring everything over the left hand side. Bring down the x squared. 2x and x is 3x, and bringing it over the equal sign is minus 3x. Then bringing over the minus 2 becomes plus 2. So now we have a quadratic trinomial which we factorize and solve. So we get x minus 2 times x minus 1. So if x minus 2 is equal to 0, x is equal to positive 2. If x minus 1 is equal to 0, x is equal to positive 1. So we're asked to solve. So now we have our x values. We need to find our y values. So we're going to take x equals 2 first of all. And we're going to take the simpler equation, which was y equals 2 times x minus 1. So y equals 2 times x minus 1. We swap the x for 2. So we get 2 times 2 minus 1, which is 2 times 1, which is 2. So we get a y value of 2. And then we take our x value of 1. We do the same thing. We swap that x for 1. And we get 2 times 0, which is 0. So we get a y value of 0. So thus, x is equal to 2 and y is equal to 2. Or x is equal to 1 and y is equal to 1. However, we are given x is greater than 1 and y is greater than 0. We're told that in the question. Therefore, x is equal to 2 and y is equal to 2 is the solution. Sometimes we have to use a calculator. If 5 to the power of n equals 3000, find the value of n correct to 4 significant figures. So that means non-zero digits. So 5 to the power of n equals 3000. We're going to take the log of both sides, or apply the log of base 10 to both sides. So the log on its own is really log base 10. So basically stick log base 10 in front of the 5 to the power of n. So we have log base 10 of 5 to the power of n. And stick log base 10 in front of 3000. So we have log base 10 of 3000. Then we're going to use law 3 from our laws of logs to bring the power, which is n, down in front of the log. So we have n log base 10 of 5 equals log base 10 of 3000. And then we're going to divide both sides by log base 10 of 5 to get the n on its own. So we're dividing by what's stuck onto the n. So we have n equals log base 10 of 3000 divided by log base 10 of 5. So then we can put this into our calculator. So we press log. So the log button on its own gives us log base 10. Log 3000 divided by log 5 equals. So we get n equals 4.974635869. And to 4 significant figures, so 4 non-zero digits, we have n equals 4.975. And we're going to check. So 5 to the power of 4.975 gives us 3001.758655, which is very, very close. And we did that by inputting 5, x to the power y, or x box, 4.975 equals.